So let's start. So we are the group 5 and we were assigned to this topic about parallel processing, typical multiprocessing configuration, process synchronization software, process cooperation, and concurrent programming. So first reporter will be reported by Myrna May Cotera. So take it away.
So, good morning everyone. So, our topic is parallel processing algorithm. So, first is what is parallel processing algorithm? Parallel algorithm is an algorithm that can execute several instructions simultaneously on different processing devices and combine all the individual outputs to produce the final result. Parallel processing, multiprocessing, 2 plus processors operate in unison. 2 plus CPUs are executing instructions simultaneously, and each CPU can have a process in running state at the same time. And the processor manager has to coordinate activity of each processor and synchronize interaction among CPUs. Synchronization is key to system success because many things can go wrong in multiprocessing system. So the parallel processing algorithm are algorithms designed to efficiently execute tasks using multiple processors or computing cores in a parallel. These algorithms are used in high performance computing, scientific computing, and other applications where large amounts of data need to process quickly. The key concept behind parallel processing algorithm is dividing a large problem into a smaller sub-problems that can be solved simultaneously by multiple processors. And each processor works on a separate portion of problem, and the results are combined at the end to obtain the final solution. Next slide. Development of parallel processing algorithm. The major forces behind the development of multiprocessing is enhanced throughput and increased computing power. And the primary benefits are increased reliability due to availability of one plus CPU and faster processing because instructions can be processed in parallel, two or more at the same time. And the major challenges are how to connect the processors into configuration and how to orchestrate their interaction. So overall, the parallel processing algorithm and techniques are important for efficiently handling large-scale computational problems in a variety of fields, including scientific computing, data analytics, and machine learning. So Fabi Ausan will continue the discussion about parallel processing algorithms so that you guys understand more about our topic. Thank you.
Thank you, Myrna. So as you know earlier in the discussion of Myrna May Cotera, so it's about parallel processing. No? So in my topic, I'll be reporting about typical multiprocessing configuration. So let's have a quick scenario about yung typical multiprocessing para namoy insight about sa typical multiprocessing configuration. So let's have a scenario sa kana mag-take og exam, di ba? Mostly kadagan mo jud kay students og dagan pod og kanang sa tawag mga classroom. So kanang dili po na siya kaya sa usa ra jud ka buok teacher na handle anang mga students na exam. So ang wato na to na is dapat na jud example natay tulo ka buok classroom. So we need three teachers para ma-work siya kanang mas dali atong oras kung usa ra ka buok teacher then madugay siya ya dagan ka siya atimanon. So it is same concept to typical multiprocessing configuration. So what is multiprocessing configuration? So wala man siya diya sa meaning no pero ako lang siya isulti ha. So a typical multiprocessing configuration involves the uses of multiple processors or cores to execute tasks concurrently, thereby improving overall system performance and efficiency. So as what I've mentioned earlier in our little insights atong concept sa atong scenario ganyan na sa teacher. So if two or more or dagan tawag ka ng processors then efficient ang ato ang pagtrabaho or pag ng iyang output ana niya. Mas dali atong mabuhat niya. So it is the same time to finish in designated tasks in a single computer with multiple processors. So this is called multiprocessing configuration. So So we have three types or three categories of typical multiprocessing configuration. First is master or slave. Next is loosely coupled multiprocessing configuration, and next is symmetric multiprocessing configuration. So ato na silang ila-ilahon guys. So ila-ila taning three types of typical configuration na. So first is the master or slave multiprocessing configuration. So what is master or slave multiprocessing configuration? So master slave configuration is asymmetric configuration. So later on I will differentiate with you kung ano difference symmetric and asymmetric. So let's first focus on the typical types or categories. So master slave configuration is a system architecture when one device or component called the master controls and coordinates the operation of one or more subordinate devices or components known as slaves. So let's give you a quick insight lang sa kanang like in real life na scenario. So in a given scenario, they're in an office where the slaves do the physical labor or tasks while the master manages its slave. So mura ginana siya na concept no. So silbi example imong boss sa company. So siya may mag-lead ninyo sa kamo na mga production which is mga slaves. So siya may tig-manage ana. So same in master or slave multiprocessing configuration inana siya og concept. So the work of the master processor is to manage the entire system consisting of files, devices, main memory, and the slave processor. So let me show you sa kanina architecture or kanina graph. So this is how it is distributed the task. So siya may so as you can see in this graph no, ang the master kay naman dire. So siya may naghandle sa to ang siya nag-maintain tanan. So siya naghandle sa main memory, siya pinaghandle sa input devices sa slave sa mga slave pod. So ang bato sa slave kay ilan iya nang trabaho ng kanang instructions ang instructions na gihatag sa master. So a master slave configuration is directs and manages the overall workflow while the slave devices perform specific tasks or provide services as instructed by the master. So mo ta kung giingon yan ha. So next is the loosely coupled processing. So awa pa dapat kan kanang advantages and the pros and cons of master and slave. So now po tayo pros and cons of master and slave. So the pros is the advantages are the primary advantage is its simplicity. Second is reliability is no higher than for a single processor system because if master processor fails, the entire system fails. So mag-rely ra jud ang whole system sa atong master. Next is can lead to poor use of resources because if a slave processor becomes free while master is busy, slave must wait until the master can assign more work to it. So mag-rely ra jud ta. So dependent jud ang slave sa atong master. So next is increases number of interrupts because all slaves must interrupt master every time they need OS intervention. So example, mag-request sila input or output request so ano. So again, next is the loosely coupled multiprocessing configuration. So let's say in this scenario para nanapotay another insight para mas masabtan ninyo ang concept sa loosely. So asymmetric po ni siya ha kay asymmetric po ni siya na multiprocessing. So let's say in this scenario in an office example, there are 3 departments. So in that department, we have the HR department, the finance department, or the IT department. So kana sila line mo na sa expertise, line sila og kanang gibuhat na trabaho. So di na sila maapektuhan sa usa-usa. So kung basa na ko akong gibuhat na situation na. So balik ta sa situation. Has different expertise in tasks in this situation. The HR department can carry out its assigned tasks independently without affecting the other departments. The production department and as well as the department perform their tasks without affecting each other. More po na siya same concept sa loosely coupled processing configuration. The loosely coupled processing configuration provides autonomy to each department in developing, operating, and maintaining their respective components independently of other departments. This approach offers benefits such as flexibility and modularity and division of responsibilities among the departments. So each department can carry out its tasks without relying heavily on other departments, resulting in a more efficient and harmonious office environment. So kani siyang loosely no kay iya jung gi-divide ang mga tasks no. Divided sila pero independent ra na sila, dili sila magsalig sa usa-usa. So a loosely coupled so what is a loosely coupled processing configuration means? So loosely coupled has several features. So features as several complete computer systems each with own memory, input or output devices, CPU and OS. Each processor's control own resources, maintains own commands, and input and output management tables. Each processor can communicate and cooperate with others. Each processor must have global tables indicating jobs each processor has been allocated. As I kanang discuss earlier, no, kay katong example nato sa atong tulo ka department kay bisag laylay sila og kanang expertise or laylay sila og kanang trabaho na gibuhat or independent sila, usar jud na yung maka-benefit ana para sa kayuhan silang company. Mora po ni siya sa loosely. Usara po nang nakakuha na nani. Usaray kanang output niya which is makatabang siya sa tanan. So next is let's read about the pros and cons. So it is to keep system well balanced and ensure best uses of resources. Job scheduling is based on several requirements and policies. Examples, new jobs might be assigned to the processor with lightest load or best combination of output devices available. System isn't prone to catastrophic system failures because even though single processor fails, other can continue to work independently from it. It can be difficult to detect when a processor has failed. So next is so mo ni siya ang ato ang concept or ang ato ang graph sa or architecture nato sa loosely coupled. So as you can see no, mo ni atong line department or line sila na processors no. They can do kanang each man they can maintain their own memory or they can maintain or can do the task by each processes pero maka-benefit sila sa usa ka output. So yes, I hope so makasabot mo sa akong i-discuss. So next is symmetric and multiprocessing configuration. So as I promised earlier, I will discuss to you the difference between asymmetry and symmetrical multiprocessing configuration. So as you can see, asymmetry is not equal or not even so. So as you can see kanya sa atong example sa ato ang duha ka book asymmetry which is the master and slave and loosely coupled. As you can see sa ato ang graph ganyan no kay dili jud siya balance. Why it is not balanced? That is not even because i-divide man nato siya naman natay divide. Example sa master and slave, i-divide niya ang workloads. Whereas in symmetric multiprocessing configuration, even ang imong trabaho, even ang imong task, malocate siya evenly. So First, let's have a brief another situation or scenario sa in real life now. So example na kay natay gi-collect na data or natay gi-collect na files no. So atong buhaton na kay siyempre ato na siya i-collect nyo. So dapat bala sa imong pagkahatagan na. So kung unsay naa diha, bala sa na siya. So what is symmetry? So symmetry is symmetrical, which means even or proportion and centralized. So sa akong discuss ganiha mo to siya. And symmetrical processing refers to a system architecture where multiple processors or cores are interconnected and share access to common memory. In this configuration, each processor has equal capabilities and tasks are divided and executed in parallel across the processors. So, moto. So, next ako pakita ninyo ang atuang graph. So, each processor is assign one or more of these subtasks to work on. These subtasks can be executed concurrently, meaning magdungan mo. So, diba, naka-grasp naman ta or nakasabot naman ta sa insight or sa meaning yun or sa atong topic which is multiprocessing, which is to multitask or to do work simultaneously. So, we simultask man, pero is it possible to multitask in a one single computer? Yes, it is possible by having multiple processors. Mabita multiprocessing ang atong topic karon. So, again, balik sa symmetrics, ako ito answer kariyan. So, the processors operate independently and can execute instructions and access data concurrently without interfering with each other. They can communicate and synchronize through the shared memory if required to exchange information or coordinate their actions. So sa atong example diri sa atong graph ay sa atong graph diri kay sa atong architecture sa may tawagan niya. So, even ra jud ang pagkuan no, tanaw even ra ang pag-distribute sa memory sa process no, processor 1, even ra siya tanan no. Dependently sila pero dapat synchronize na sila kung example mo na siya sa queue bitaw example ha sa in a queue, imagine lang in a queue kana example kana siya na task kay di pa jud ka mag-proceed ana sa next task kung ay dili kana pwede siya magkuan sa in a queue kana di siya mag-proceed sa next task if wala pa na siya nahuman o pa na siya kung na-complete. So dapat sila dungan gina sila nahuman. So inana ang iyang concept. So what are the advantages of symmetric over loosely coupled configuration? Since same raman sila o kanang meaning sa kanang they work independently with only one goal no in a certain goal. So ang symmetric lang jud na nakalainan jud sa symmetric is it is more reliable, uses resources effectively, can balance loads well, can degrade gracefully in the event of a failure. So most difficult to implement because processes must be well synchronized to avoid problems of races and deadlocks. So next. That would be all by multi-processing configuration. So I hope you understand it. So the next reporter is Ella, Miss Ella Vilasa.
So the next topic we will discuss is the process synchronization software. So when we say process synchronization software, so it refers to a software mechanisms, mga siyang software mechanisms and techniques that are used to coordinate, so say international coordination and control the execution of multiple concurrent processes or threads in a computer system. So the main point of this process synchronization is to coordinate and control the execution of multiple processes or threads within a computer system. So this ensures that these process or threads work together harmoniously and share resources effectively. So na siya diri ang balance or kanang ang equal na kuan. In preventing issues such as race conditions, mga deadlocks, and inconsistent data access. So next slide, please. So here we have the two types of synchronization and categorized as one of the following two types, the independent process and the cooperative process. So when we say independent process, so the execution of one process does not affect the execution of this process. So in the independent process model, so the processes are self-contained and communicate with the outside world through explicit input and output operation. So they may share common system resources such as the CPU, but they do not interact or exchange information with other processes in the system. So in the process. Next is the cooperative process. Cooperative process is a process that can affect or be affected by other processes executing in this system. Unlike the independent process, cooperative process typically rely on inter-process communication mechanisms such as shared memory, message passing, or synchronization primitives like semaphores or monitors. So we'll discuss that later. To exchange data, coordinate activities, and ensure mutualization in accessing shared resources. So those are the two types of synchronization. Next slide, please. So here, as we can see in the image presented, so for example, mo na siya ang example sa kuan kanang kung dili ta makakuha sa process synchronization of operating system. So here, for example, consider a bank that stores account balance of each customer in the same database. So natay user 1 and user 2. Now, supposedly, you initially have X rupees in your account. So here, sa atong card balance. For example, what takapos sa atong kuan amount. So we have here the X rupees in your account. Now you take out some amount of money from your bank account at the same time. So the same time sila na-process. So some tries to look at the amount of money stored in your account. So as you are taking out some money from your account after the transaction, so of course the total balance left will be lower than X. So kung kuha makakuan ang mga of course mo lower yun sa X. But the transaction takes time and hence the person reads X as your account balance which leads to inconsistent data. So nadiri ang kanang murag kuan gani for example kay mag-hack sa imong kuan makita nimo kung makita nimo kung ma-hack imong account or imong balance sa imong kuan so ari makuan ang kuan inconsistency of data. So here in the above image kini sa atong present sa atong kuan sa screen. If process 1 and process 2 happen at the same time, so one is example, happen at the same time, so user 1 will get the wrong account balance. As well, because of sa process ni user 1, process 1 being transacted in the balance is X. So here, the inconsistency of data can occur when various processes share a common resource in a system, which is why there is a need for process, so maong mag-need ta og process synchronization in the operating system. So next, please, next slide. So here, how process synchronization in OS works. So let us take a look at why we exactly need the process synchronization. So for example, if a process 1 is trying to read the data present in the memory location or here in the shared memory, so while another process 2 is trying to change the data. So sila duha ang kuan ni process na kana ang kuan data present in the same location. So there is a high chance that the data read by the process 1 will be incorrect. So as what I have kanang kuan talk a while back. So here. Please proceed to the next slide. Next slide. So here kini siya ang different elements, sections of the program sa katong process synchronization. So intersection. So mo occur ang intersection kay katong time nga kanang musod ba katong the process gani musod ang usa ka users sa kanang kana nga shared memory or katong data present in the memory location. So mo na mo occur ang intersection. So the intersection decides the entry of a process or the entry of the process. Next is the critical section. Ang critical sections allows and makes sure that only one process is modifying the shared data. So to avoid kadang inconsistency of the data, dapat usa ang maka-access anak nga data para to avoid inconsistency. So mo na siya ang kanang present as the critical section. Well, the exit section is the entry of other processes in the shared data after the execution. So after kanang makuha niya, maka-access ang kanang nasa critical section, kung mo-exit na siya, mo na siya ang called as the exit section. Entry of the process is shared data after ang mo na siya handled by the exit section. Well, the remainder section, mo na sila ang mga waiting. Kato pa sila ang musod pa sila, mo na sila ang called as the remainder section. So the remaining part of the code which is not categorized as above is contained in the remainder section, mo na sila ang mga waiting. Next is some common mechanisms includes locks are also called as the mutex. So these are the binary synchronization objects that allow only one process or thread to access a shared resource at the same time. So processes or threads acquire a lock before accessing the resource. So here in the locks or also known as mutexes, so they only allow one process or thread to access a shared resource at a time. So a lock is acquired before accessing the resource and released after one motion. Next is the semaphores. So semaphores are integer variables used for signaling and synchronization. So they can be used to control access to resources or to coordinate the execution of process or threads. So ang semaphores can have two types: the binary semaphores, which is have a value of 0 or 1, and counting semaphores, muna sila ang mga values greater than or equal to 0. Next is the condition variables. So when we say condition variables, these are used to block processes or threads until a certain condition is met. So they are often used in conjunction with locks or mutexes to build more complex synchronization process. So they allow threads to wait until a certain condition is satisfied before proceeding. So condition variables are typically used in conjunction with locks to provide more complex synchronization patterns, such as producer, consumer, or reader-writer scenarios. Next is the barriers. So barriers are synchronization points that ensure the group of processes or threads reach a specific point in the program together proceeding further. So they are kani ang various they are commonly used in parallel computing or parallel processing scenarios. So various are synchronization points where multiple processes or threads must wait until all of them have reached that point before proceeding further. So katong discuss katong sa process of synchronization. Na waiting, na critical region, na asay ka nang nasa kanang on the process pa, exit region, exit section. Message passing. So message passing, this approach involves processes or threads communicating and synchronizing by sending message to each other. So messages can carry data or signals indicating specific actions. So message passing involves communication between process or threads through message queues or channels. So processes or threads can send message to each other, which enabling synchronization and detection. So this message passing can be synchronous or asynchronous depending on the communication mode. Lastly is the read-write locks. So these locks provide a mechanism for allowing multiple readers or a single writer to access a shared source. The readers can access the resource concurrently while writers have exclusive access. So here in read-write locks, multiple threads can read the resource simultaneously, but only one thread can write to it and no other thread can read or write during at the time. So it's the process. So these mechanisms provide different levels of synchronization and coordination. And their selection depends on the specific requirements and constraints of the application or system being developed. So here we have the mga requirements of synchronization. So the following three requirements must be met by a solution to the critical section. First is the mutual exclusion. So if a process is running in the critical section, katong nasa critical section, no other process should be allowed to run in that section at that time. So dapat one at a time lang. Next is the progress. If no process is still in the critical section, wala pa mga processes sa kanang critical section and other processes are waiting katong remaining section, katong remainder section outside the critical section to execute, then any one of the threads must be permitted to enter the critical section. So the decision of which process will enter the critical section will be taken by only those processes that are not executing in the remaining section. Katong entry section. Next requirement is no starvation. So starvation means a process keeps waiting forever. To access this critical section but never gets a chance. No starvation is also known as bonded waiting. Wala sila mga bounded waiting na wala yun, di na sila naka-access sa critical section. But wala sila chance na naka-access sa critical section. Next is a process should not wait forever to enter inside the critical section. So there should be kanang huli po ay there should be process ba kanang dapat tanan nakasulod sa one at a time siya. So a process should not wait, di na siya magstay, dapat kay makasunod siya sa critical section. Next is when a process submits a request to access its critical section, so there should be a limit or bound, which is the number of other processes that are allowed to access the critical section before it. Lastly is after this bound is reached, this process should be allowed to access the critical section. After this bound. So that's it for the requirements and the process of the synchronization. So in the synchronization, there should be a coordination or kanang processes. That's it for the process of synchronization.
In the operating system is a process that get affected yeah, makahilabot siya sa laing nga processes. So inversely sa independent process, it is an operating system, one that does not affect or impact any other processes of the system. It does not share any data with other processes. So next slide, please. So there are methods of cooperating process in OS. So cooperation by sharing and cooperation by message passing. So next slide. Cooperation by sharing. Cooperation by sharing is the process in OS can communicate with each other using the shared resource. Change the information by reading or writing data to the shared region. You can use a critical section that provides data integrity and avoids data inconsistency. So next slide, please. Cooperation by message passing. The operating process in OS can communicate with each other with the help of message passing. The production process message, and the consumer process will receive the same message. So there is no concept of shared memory. Instead, the producer process will first send a message to the kernel, and then the kernel sends that message to the consumer process. A kernel is known as the heart and the core of an operating system. The kernel interacts with the hardware to execute the process given by the user's space. It works as a space and a hardware. Functions of the kernel include process management, file management, and memory management, and also input-output management. Next, please. So this is the example. Mo ni siya ang producer, the buffer, and the consumer. Mo ni siya ang example sa kan message sharing. So next, please. So buffer. Buffer memory can be of two types. Unbounded buffer. It is a kind of buffer that has no practical limit on the size buffer. The producer can produce new information, but the consumer might have to wait for them. The second one is the bounded buffer. It is a kind of buffer. Here, the consumer has to wait if the buffer is empty, while the producer has to wait if the buffer is full. But here, in the process consumer problem, we have used a bounded buffer. Next. So, the need of cooperating process in OS. So there are four types of this. Number one is the information sharing, computation speed, convenience, and modularity. Number one, the information sharing. As we know, the cooperating process in OS shares data and information between other processes. There may be a possibility that different processes are accessing the same file. Processes can access the files efficient. Next slide, please. The computation speed. When a task is divided into several subtasks and starts executing them parallelly, this improves the computation speed of the execution and makes it faster. Computation speed can be achieved if a system has multiple CPUs and input-output devices. When the tasks are assigned into several subtasks, they become several different processes that needs to communicate with each other. That's why we need cooperating processes in the operating system. Convenience. A user may be to these processes need to cooperate so that every processes can run smoothly without interrupting each other. The last one is the modularity. We want to divide a system of complex tasks into several different modules, and later they will be established together to achieve a goal. This will help in completing tasks with more efficient as well as speed. So that's
So concurrent processing system is a computing model in which multiple processors execute instructions simultaneously for better performance. Concurrent occurs when something else happens, kanang kay gibuhat multitasking bitaw. The tasks are broken into subtypes which are then assigned to different processors to perform simultaneously, sequentially instead, as if they would have to be performed by one processor. Concurrent processing is sometimes synonymous with parallel processing, but dili sila the same, okay? Sa parallel processing manggod is you would need to require multiple processors. Kanang idungan bitaw nimo siya, like lahi-lahi siya nga, like for example, lahi-lahi nga cellphone nga magdungan kag duwa, ang isa garan Arknights, ang isa garan og another idle game, then ang isa another nasad nga idle game, gidungan bitaw siya. Whereas concurrent processing is actually doable with just one processor. Then i-explain ako later how giunsa niya nga usa ra ka processor, but it can run multiple computations at the same time. So next please. Lagi. So, Magstoryalis sa disadvantages allows multiple applications to be executed or run simultaneously, thus increasing efficiency and the total output of workstations. It promotes better utilization of resources and allows unused assets or data to be accessed by other applications in an organized manner. This also improves average response time by reducing the waiting time between threads. Applications do not need to wait for the active operation to finish or other applications to complete their functions. Unlike sa ganihan, gi-explain, di ba? Kailangan nga naay maghuwat nga mahuman na isa ka process. Concurrency does not need to wait. This is done by using free resources when given the opportunity, as threads can use a variety of resources to complete their objectives. Next, please. It also helps in improving the operating system's performance. This is possible due to different hardware resources being accessed simultaneously by separate application or threads. This is different from the point above, as it helps with the simultaneous use of the same resources as well as the parallel use of different resources. It can also help integrate different resources or applications seamlessly to finish the main objective as fast as possible. The next is disadvantages. Concurrently running applications must be protected from one another to cause as little interference as possible. Kaya nagdungan-dungan man siya, yung labi na mag-multitasking, di ba, sometimes, imong answer sa math, imong nabutang sa English, ingana siya mahitabo niya usahay.
Parallelly running applications must be coordinated, synchronized, and scheduled in a highly organized manner with special importance placed on allocation and sequential order. Additional systems must be designed in order to facilitate the coordination of applications. Next, please. More complexities and performance overheads are noticed in OS when switching between applications. Performance can even be negatively affected or degraded due to too many processes being executed at the same time. So, di ba nisgot ko nga, giunsa ni concurrent nga mag-run og mga multiple computations at the same time without having to wait for one computation to finish. Next slide, please. So, concurrent processing, mogamit siya like multi-programming environment. There are multiple tasks shared by one processor. While a virtual concept can be achieved by the operating system, if the processor is allocated for each individual task, the virtual concept is visible if each task has a dedicated processor. Pwede siya nga mag-usara jud iyang processor nga magamit. Next would be multiprocessing environment. Wait, balik. Two or more processors are used with shared memory. Only one virtual address space is used, common for all processors. All tasks reside in shared memory in this environment. Concurrency is supported in the form of concurrently executing processors. The tasks executed on different processors are performed with each other through shared memory. So, wapang kahisgot yun sa nga si concurrent manggod mag-switch manggod siya og task like magsige siya constantly siya nga mag-switch bitaw. So for example, bisag pananahuman if mag-need na ani nga kaning competition, balik sa mag-switch siya between applications to efficiently use nga ang iyahang oras bitaw. So muna siya reason nga nung paspas jud kayo si concurrent processing. Then last would be next please. Distributed processing environment. Two or more computers are connected to each other by communication network or high-speed bus. There's no shared memory between the processors. Each computer has its own local memory. Hence, a distributed application consisting of concurrent tasks which are distributed over network communication via messages.